percents. You've probably worked with percents already, but let's take a look at them again. If I have, and we'll call this a whole item, and let's say I take 25% of that. Well, we know that this would be a quarter, right? We say I'm going to take this much out of here. So I have the whole, I take 25%, which is the same thing as saying 0.25, right, in decimal, or I could say that's 1/4. And I know I can take this decimal and put it into a rational form because the decimal stops, it terminates. Now, most of the time in mathematics, if I'm going to use a percent, I either need to have it in this decimal form or in the fraction form, right? But we do know that if I take a percentage less than 100%, I get a part of the whole. So let me write that in words. I get a part is a percent of the whole. Now we can write this in a formula. And when I write it in a formula and when I use it in a formula, I'm going to use the decimal or fractional form. So let's say A is that part, or a part, is in mathematics often is a equal sign. So the part equals the percent, I'll call that P, times the whole. Let's call it capital W for the whole thing. So a percent times the whole thing is equal to how much I'm dealing with. So in this case, let's say our whole pie here was equal to, say, 10 ounces, right? And I want to know what is 25% of 10 ounces. So I would, in this example, I would say, well, the amount that's a part, it's smaller, right? It's going to be 25%, 0.25, times the whole amount, which we said was 10 ounces. So 0.25 times 10 is 2.5 ounces. So 25% of 10 is 2.5. All percent problems can be written in this way. A is equal to P times W. Now some books will use different letters. They might say A is equal to P times B, or we could use any variables we wanted, right, in here. But the key is this percent is in decimal. Let's do another one. Let's say we have 3 is 50% of 6. Well, is that a true statement? Let's write it in terms of a formula. The formula is A is equal to P times W. So we have 3 is 50%, 0.5, of its multiplication of 6. 0.5 times 6, well, that's half of 6, right, is equal to 3. So this is true. This is a true statement. Now, if I take the formula, I really only need any two of these values, right? Any two values I could solve for the other one. So let's do some where we solve. What is 20% of 150? The first thing I'm going to do is put it in terms of the formula. What is the part? 20% of 50. Of, you can think of as multiplying. So this is multiplying. This is the whole amount, right? 20% is my percent, or P, and is an equal sign. So if you think about it, I have P times the whole amount is equal to what? Well, we don't know, and in this case we'll call it A. So let's write this in terms of the formula. A is equal to 20%, 0.2, times the whole amount, 150, which is equal to, let's see, 2 times 15 is 30, so this would be 300. I have a decimal point here, so I'd move it, so the answer is 30. So 30 is 20% of 150. Again, I've got my formula. A is equal to percent times the whole. Now I'm not putting that multiplication sign in here because we know it's multiplication. So another example, 5 is what percent of 150? All right, so what are we looking for? What percent? That's our unknown. Right? Nowhere in this problem have I been given a percent. So again, I'm just going to put it exactly in the form of this formula, and I say 5 is what percent? Well, P, that's what we're looking for, times 150. And now I just solve for P. How would I do that? Sure, divide by 150, both sides, right? Because it's an equation. So 5 divided by 150 is equal to P times 150 over 150, which we know this is equal to 1, so it kind of goes away. And I'm left now, I'm going to switch this. I'm going to say P is equal to 5 over 150, or 1 over 30. Okay, 5 over 130. If we put this in a calculator, 1 divided by 30, we get 0.03 repeating. So P is approximately, if I write this in percent, 3.3%. So 5 is about 3.3% of 150. Let's take one more look at this. There's another way I could do this problem. I know I want to find percent, so I'm going to start with A is equal to P times W and solve this for P before I even put the numbers in. So this is a formula. I'll solve it for P, so I'm going to divide both sides by W. You can see this W goes away, and I'm left with P is equal to A over W. P is equal to A over W. As long as I know what these things are, remember A was the part, or a part, and W was the whole amount, so my percent would be A, which the part was 5, and the whole amount was 150. So again, we get the same answer, which is a good thing. It's always a nice thing to work it two different ways in mathematics and get the same answer, and it tells me I've done it correctly. Alright, I think that what I like to do, because I'm not one to memorize too much, is to remember one formula. If I can remember this particular formula, A is equal to, or a part is equal to the percent times the whole, then I can always substitute in those numbers that are given to me. If I know how to solve a linear equation, and we've been working with those quite a bit, so you should remember that. This is just a linear equation, right? If I know how to solve those, once I plug in all the numbers, it's simply a matter of isolating the variable. Good.